continue with what we started, and these are the people that are in the room. Your presenters, Maina, Kiforo, Esther, Patricia Hannington, and Priscilla. And then we have visitors from South Africa. I hope they are in. Karibuni sana. Kathy, Maggie, Jackie, Piakazi, Tuli, and Tabisa. And then we have the following schools that have been presented: Kimbigua, Kirasha, Togoto, Gitombo, Kibi, Mihoko, Wangware, Miiri, Yawanda, Katara. And of course, we have Togoto TTC that have also been presented by Nancy, Roy, Mwiri, Michael, and Matthew. I hope that all of them are here. So we are going to look at non-routine problem solving in mathematics. That is what we are going to look at in the SRL model, and that is the self-regulated learning. So our learning outcomes today are as follows. We will explore the requirements of solving the non-routine problems. Then we shall definitely solve routine problems as we go along, and appreciate the importance of solving the non-routine problems. And the success criteria is as shown on your presentation. We will participate in an activity solving a non-routine problem. That will be key. Then we shall look at the review of various examples of how to teach non-routine problems. And then, as usual, we shall plan an activity that you can use in your school. Remember, that is actually what we expect you to carry home. What is it that you can carry home from the session today? So we have the differences there between the routine and the non-routine problem. And the non-routine problems, as you can see, are complex problems that require some degree of creativity and originality to solve. They're not things that you will remember using the prior knowledge or substitute using the prior knowledge. No, they will require a degree of creativity and originality to solve. Every non-routine problem is a new problem, just like the life problems. Every problem is a new problem, and you have to find a creative way of solving it. Non-routine problems are typically do not have immediate apparent strategy. You have to think really hard to be able to get the solution. And then these problems can be solved in multiple ways. There is no one jacket for all. There are multiple problems in which you can solve the non-routine problems. The routine problems are, you can solve in a routine way. For example, you can use formulas, you can use the log table. If you remember the log table, you can use the calculator, okay, to solve the problem. So they are practical in nature. And once you've taught somebody the formula, then they can be able to substitute and solve that problem. For example, in literacy, I dash a feeling it will rain. I dash a feeling it will rain. Who can tell us what the answer is for that one? Somebody who can tell us what is the answer for that literacy problem? I dash a feeling it will rain today. Yes. Dr. Gyoko, please mute some people. Who can tell us? Who can give us a solution? Someone?
Yes.
Give us a solution to that?
Yes.
Yes?
I have a feeling.
I have a feeling. Good. He says that you have a feeling, or I have a feeling it will rain today. So going back to the subject-verb agreement rule in English, then you can only use the word have. You cannot use the has, you cannot use am, you cannot use will have. Because going by the subject-verb agreement, you can only have one answer. So that is a the other numeracy one. Somebody solve the numeracy one. The timestamp. Somebody read for us the timestamp.
Enos, unmute yourself. I have to mute everybody.
Somebody read for us the timestamp. Thank you, Dr. Gyoko. Someone.
Okay, this. Hello.
Hello.
In the chat we have.
Yes.
Somebody is saying the answer?
It is 7 minutes past 3.
Okay, so somebody says it is 7 minutes past 3. And this is something that your teacher taught you, and it will remain that way, and it will never change. You only have to look at the clock, you know where 12 is, you know where 6 is, you know where 3 and 9 is. Even if that clock was to be turned upside down, you'd still read the answer correct, isn't it? So that is a routine problem. Dr. Gyoko, you are looking at the charts?
I think in the chat, somebody has said 7 minutes past 3. Yeah, some people are answering in the chat, yeah.
Okay, good. Thank you. Some people answering in the chat. Thank you very much. So those are routine problems, and those are problems that can be solved in a normal routine way. But we have non-routine problems. This is a good example of a non-routine problem. If you are halfway between Nairobi and Machakos, how far away are you from Thika? Take some 2 minutes to solve that problem. Okay, that is where the signpost is. Machakos is 35 kilometers. Nairobi is 35 kilometers to your right. Machakos is 49 kilometers to your left, and Thika, 17 kilometers to your right. If you are half between Nairobi and Machakos, how far away are you from Thika? Please solve that problem. Five minutes. 3 minutes. Put it in your chat or in your WhatsApp chat. As soon as the answer starts streaming in, Esther, could you please read for us?
So far, none.
Okay. Perfect example.
And also you can see how non-routine this can be.
Yes, it is quite non-routine. It's not as quick as a have or the timestamp. This is completely different. You have to think creative. If possible, I know most of you have taken a piece of paper and they're writing down or drawing so that they can be able to see it. And this is something
From the
that,
WhatsApp, eh?
Yes.
Matthew says 59 kilometers.
Okay, so Matthew says 59 kilometers. We'll see whether that is correct.
Lucy Mwaura also says 59 kilometers.
Okay.
Then Magode says 59 kilometers.
Magode 59 kilometers. Yes. From Thika, remember, it's from Thika. How far away are you from Thika? More answers?
Robert Omwanwa says 20.
20? And notice it's the same question, but look at the way the answers are coming. The routine problems, you had one answer and it is either right or wrong. Keep bringing them on. Okay, in the WhatsApp, any answers in the WhatsApp, Dr. Maina?
Miss Independent says 59 kilometers. That is from the WhatsApp. And
Yes.
Anne says 22 kilometers.
All right. Okay.
Somebody from the chat says 41.5 kilometers. That is Michael Aweru.
Okay. Okay, so let us look at the teacher solution and see how well.
Are we talking about the same question?
Yes,
are we talking about the same question?
We are talking about the same question. Just a reminder. We are talking about the same question. Okay.
It is
So-
24 kilometers.
24 kilometers. Good.
Okay.
The possible working is there, all right? So we are told that Machakos, we are going to use a number line. Machakos is 49 kilometers away from the signpost, and Nairobi is 35 kilometers away, okay, to the right. So it means that we are having 84 kilometers in total between Nairobi and Machakos. So if you are halfway, then it means that you are at 42 kilometers, isn't it? Right? Between Nairobi and Machakos, because the problem says you are halfway between Nairobi and Machakos, which is at 42 kilometers. So you are at 42 kilometers, which means the distance from where you are to the signpost will be 42 minus 49, which is actually 7 kilometers. 49 minus 42, which is 7 kilometers. So you are 7 kilometers to the signpost. Remember, this is halfway between Nairobi and Machakos. Therefore, it means if Thika is 17 kilometers from the signpost and you are at 7 kilometers away from the signpost, then it means that you are at 7 plus 17 kilometers, which is 24. How many got 24?
Only one person.
Only one person got 24. Maybe tell us how you worked, because this is the way that I work. And for you, how did you work? The person who got 24, please unmute yourself and tell us what you did.
Good morning.
Good morning.
Yeah, Michael Macharia from Bogota.
Morning.
Yes.
And the same way you have done it,
Mm-hmm.
that is how I worked it out.
Okay, so you used the same way, number line, isn't it? That was kind of the easiest way that you could solve using the
that was the easiest way to
exactly. And the person who got 49, please tell us how you got your 49. Maybe you could be also right. The person who got 49, please tell us how you got your answer, how you arrived at your answer.
It is 59.
Oh, they said 59, yes.
Yes.
How did you arrive at your answer? The person who got 59, unmute yourself and tell us how you arrived at the answer.
I'm Lucy.
Yes, Lucy.
I got 59.
Mm-hmm.
I took the total for Nairobi and Machakos, that is 35 plus 49. I got 84.
Okay.
And then because they are talking of halfway between Machakos and Nairobi,
Mm-hmm.
I tried to get the 84 divided by 2 so that I can see the middle part of that distance.
Yes.
And then after getting 42, I added to 17. That is from Thika to the distance between Nairobi and Machakos. 42 plus 17, I got 59.
Yes.
Yeah.
Okay. So that was also the way she worked it out. But notice one thing, that she had to think hard. You had to think hard. Look at the distance between the two, have it, and then add the distance from there to Thika and so on. It is not a routine way of solving the problem. The bottom line is that it's a non-routine way of solving the problem, and you think very hard. So if I was a teacher, I would have given her marks a tick for finding the distance between Machakos and Nairobi. That would be a tick. Then at the point at where she is, that would be a tick. So I'd give her several ticks before then I discuss with her the 59 and how we arrive at 24. So this is a non-routine problem. So we are going to do a quiz. This is yet solving routine and non-routine division. There is a quiz. I will request Dr. Maina to upload the quiz so that we are able to see the quiz. Dr. Maina, please.
Okay, let me share my screen. So let me share my screen so that we do the quiz.
Yes.
So you can go to myquiz.com and It's coming up. Let us see if you can see it. But you can go to myquiz.com. Type joinmyquiz.com.
myquiz.com. Let's all type myquiz.com.
Yeah. And we see where it's taking you. I'm trying to share my screen so that can you see my screen, Enos?
Not yet.
Not yet.
And now?
Yes, but you have not uploaded anything.
There it is.
Now we can see.
So, yeah, go to joinmyquiz.com and enter that code.
On your phone.
Yeah, type joinmyquiz.com and enter that code. It will ask you for a name. They just give yourself your name so that we know who is there. Search. Search. So we are waiting for you to join.
Dr. G, I think you need to clarify. I'm seeing people writing joinmyquiz.com on the chat so that they know they're supposed to type that on their phones.
Type that on your phone.
Let me put that on the chat so that they can be able to just click it. That's okay. That's okay.
The link, eh? Okay, that's okay.
So let me see if I enter the link in the chat. So that just press the link. There it is. Just press that link. It will take you to the quiz.
Mm-hmm.
Have you seen the link?
Yes, it's there.
Yeah, just click that. You can copy that in WhatsApp, Esther. Just click on that.
Yeah,
click on
let me
the
do it.
link in the chat.
Let me share it.
So I can see 2 people have joined, Michael Macharia and Masi Maura. Four people have joined. Rachel Mwoki, Joyce Kimanga. Michael Waweru. So we have 5 people. We are 33 in the room, so we're expecting 33. Magdalene Karanja. So we are now 6. We're actually 44 now. We are now 10. So a quarter of the group has joined. Yes, sir?
Okay, 72805.
Good. We have 12 people now, a third of the group, because our class now has 44 people. Thank you, Kathy, for joining. So we now have 13 people. Okay. We are going to start in a minute, so make sure you join. Otherwise, you'll just follow others as they are doing it here. Great. Now we have 16 people, almost halfway. 17 people, 18, 19. So we have 20 people. Enos, you let me know when to start. What number do you want to be in the room so that we start?
If we get to 20, I guess will be good. That will be half.
Okay. Miss, we're actually 43.
Oh, okay.
So we are 19 now. Let us see 3 more people and then we start. Actually, we are 20 now. Can we get 3 more people? Because I can see we are 44 now. And then we are going to start.
I think that's a good number.
Okay. So according to the facilitator, the class monitor is going to start the quiz.
Yes.
And we'll take it.
Yeah.
So you'll see questions on your devices, answer them. You press the correct answer. So you can see some people have already started answering. 5 people have answered correctly. So people already in the 3rd question. Some people already in the 3rd question. And you can see the leadership board is changing.
Yeah.
So it's not first come, first serve. It's who gets correct.
Who gets correct?
So you can see things are changing. And the thing is, we are not competing, but we are learning how non-routine questions look like. And our teacher who taught us has already done 4 questions. Almost finished.
Already.
It's almost finishing. But you can see some people are shooting from below and all the way up.
Yeah.
Like Michael Macharia, Edith, and one person has finished. Remember, they have finished with 4,580, but you can still beat that if you answer fast. You can see Kathy is at 3rd position and approaching there, yeah. And Edith is there. And the board is changing. So let's finish. Once 5 people finish, we are going to close the game. You have the idea is for you to get what Mr. Enos is teaching. Wow, you can see people are coming up.
Yep.
Kathy has jumped up. And Edith has come back there. Okay, great. So we are almost having 10 people finishing. You can see how the leadership board is changing. Wow, you can see that spelled she's came up. So at least 4 people have finished. And you can see how the leadership board is changing. So we have 5 people who are finished. Let's wait for another 5 and then we are done with the activity. Okay, Rachel has come up. And then Joyce Kimanga, she's still working on the last question. She might shoot up.
Yeah.
Charia is there. So we are waiting for 10 people to finish, then we close. You can see most people have 2 questions to go. Lilian Wamboi, Joyce Kimanga, and Nancy Muchiri. You have 1 question to go so that we have the top 10 people. But even those who are below, you can also come up. You are seeing Frida Murungi has just jumped up. Florence has finished and she has jumped to 11. So, yes, Lynette has come up.
Notice that the time.
Essence of some non-routine question, and these are grade 4. We took a test from grade 4. That is what we are sharing. We took a test from grade 4, and now let us end the game in the next 50 seconds. So for those who are finishing, please answer. Press the answer for the first few questions. We have 40 seconds. Make your last choice in 30 seconds.
Your last salvation.
Yeah, you have 20 seconds. And now it's countdown. And time is up. So Enos, I'll now share you the leaders table. You see how it looks like.
Yes.
Yeah, so let me end the game. So that is the leaders table. You can see. Maybe we need to appreciate those people.
Yeah.
And you can see the mastery part. Those are people who got 100%. Those 4 people.
So
and then this is the podium.
The podium.
And then you can see the question. Class accuracy was 70%. The toughest question was question 1. The longest question, the question which took 45 seconds, was question 4. And this is the standing list. Thank you.
Thank you, Dr. Maina. Let me just go back to the screen. Okay. So notice that the easiest question that he says was solved quickly, that was definitely the routine problem. And the one that took people some time definitely must have been the non-routine problem, isn't it? Is that what you observed,
Sure.
Dr. Maina? Yeah, because
Yes.
the non-routine problem, you had to think critically, you had to take your time and see how well to solve that problem, all right? So that is the nature of the non-routine problem. So in the non-routine problems, there are some skills that we get to learn, and these are skills like creativity, originality, and initiative. These are skills that we learn within non-routine problems. For example, technology design and programming. We have seen so many creative aspects of technology coming in, and these are ways that they have learned how to solve non-routine problems. Critical thinking and analysis is yet another skill that students are exposed to when you give them non-routine problems to solve. For example, complex problem solving. We also have leadership and social influence as another skill that comes out of the non-routine problems. And that is basically on emotional intelligence. People are able to control their emotional intelligence and see how well to solve the problems. You have seen children trying to do some things and they defeat them, they kick it because they are hot-tempered or something. But if you introduce them slowly to non-routine problems, then they will know how to be able to control emotional intelligence and deal with those issues. Reasoning and problem solving is yet another skill that children get to be exposed to when you get them into non-routine problems. And definitely problems such as system analysis and evaluation will come out of such skills. But as we are getting into the non-routine problems, there are some things that we shall have to shed. Things like memory, verbal, auditory, and spatial abilities, those are things that we shall have to shed from us. Management of financial and materials resources, for example, will have to go. Technology installation and maintenance, these are things that will definitely have to go. Nowadays, you click a button and the program just runs itself and it just installs itself the way it wants. It's not like those days where you have to think hard on how to to type in the DOS command and get the problem. And so nowadays, there's nothing like that. So that we have to go. Reading, writing, math, and active listening, those are also skills that we shall have to shed off. Management of personnel, these are skills that we shall have to shed off because either the personnel are managing themselves or we have systems that are doing this on your behalf. Control, quality control and safety measures, safety awareness, this will definitely have to go. Coordination of time management, okay, that is a skill that we shall also lose, and technology use in monitoring and control. So as we are moving further into the non-routine issues, as we are moving further into the way things are changing in the world, we are realizing that there are some things that we are having to shed off, and we are now putting on that cap of creativity, we are putting on that cap of imagination, problem solving, and so on. This therefore means that we have new jobs coming up. The jobs that are there now are not the same jobs that have been there. Jobs are changing, all right? So I would like you to note down at least 2 jobs that were not there when you were a student in school, but they are there now. Please note down in your chat some jobs that were not there when you were in school, but right now we have those jobs. Take a moment, type in your chat. So far, haven't seen anything on WhatsApp.
Maina says mobile phone repair. Then Kathy, web designer. Laptop repair. Then Michael Waweru says computer science. The other person, ICT manager. Oh, there is drone builders from Maina.
Yes. These were jobs that were not there while you were in school. They are completely new. So the question is, did our education prepare us for these jobs at that particular time? Right? That's the question that we are asking ourselves. So what jobs are we preparing our learners for? What jobs are we preparing our learners for currently? Right? So somebody said that we are currently preparing learners for jobs that do not yet exist. Use technologies that haven't been invented in order to solve problems we don't even know are problems yet, right? So we are preparing learners for jobs that do not exist, and we are using technologies, we are preparing them to use technologies that have not even been invented in order to solve problems that we don't even know that are problems. So that should actually be the guiding factor when you are walking into your classroom or when you are planning your lesson. So we have some new jobs, and some of them I think some people have mentioned, like weather design engineer. That is a new job. Artificial intelligence lawyers. So far we just have lawyers, but we do not have artificial intelligence lawyers. Those are new jobs that are coming up. Human organ engineer. We have heard a lot about human organs and how they can be transferred and how they can be changed, how they can be modified. So we are preparing learners for such jobs. Nanotechnology engineer, and you know the nanotechnology, the nanosinker technology. You have the robot sports promoter. These are jobs that we are preparing our learners for. 3D cutting printer designer. I think most of you have heard about the 3D printing. Okay, so these are some of the jobs you're preparing our learners for. Autonomous transport specialist. That's also new jobs. Memory augmentation specialist. 3D food printer biochemist. Augmented reality. Drone fleet manager. I think somebody mentioned that. Robot behavior designer. Gene programmer. And human technology integration specialist. So these are jobs that some of them are not even there. But looking at the way technology is moving, looking at the way the world is moving, these are jobs that will be here in not so long a time. So this could be some of the jobs that we are preparing our learners to. So how can we prepare our learners for jobs like these ones if we are just giving them routine problems, right? So for us to prepare our learners for such jobs, we then need to start thinking about non-routine ways of solving issues, non-routine ways of solving problems, so that they can be prepared for that which is not already there. Somebody has talked about problems that we don't even know are problems yet, all right? Okay, so based on what you have discussed today, I would like you to think about things that you will implement in literacy and numeracy in your class. We'd like to build a portfolio, okay? Put in your pedagogical ideas, core skills, enhancements, strategies, learning object, lesson plans, and reflection practices. So would you please note down some of the things that you are taking away from the session that you just had before we go into class, a mathematics class? Take a moment and input that in your portfolio. Okay, someone to mention one thing that they take home. Just mention one thing in the chat that you take home from that session before we go to class. Yes. Yes. Something that you take home.
From the chat, Edith says, being creative and turning creativity into action. Then Wilter says, non-routine problems enhance critical thinking and problem solving. Then somebody from WhatsApp says, that is Frida, I should prepare learners for non-existent jobs.
Okay, good. Prepare learners for non-existent jobs. Perfect. Okay, so we are now going to model use of non-routine problems in a classroom. So I will be your math teacher today, and we are moving on to math. Good morning. There's another.
Enos, you'll unmute yourself. There was somebody on Anduthi.
Okay, thank you. So good morning, class.
Good morning, teacher.
I only have one student in this class. Eh? Where are the others?
Good
Did you have your
morning.
breakfast?
Good.
Thank you.
Good morning,
So,
sir.
thank you. So in our last lesson, we talked about adding 2-digit numbers to 1-digit number without regrouping, with some not exceeding 100, right? For example, 22 plus 7. You put them down and find our answer as 29. Okay? We also saw this as a word problem. For example, we say that we have 22 girls who came to school. 7 more girls came to school. How many girls came to school? Can one of you tell us what we did? What did we do to solve this problem? Esther?
We took 22 girls and added 7 more.
Okay.
Then we get the total to be 29.
To be 29, isn't it? And I also showed you how to use sticks to add. So we collected 22 sticks and added to 7 sticks. And then we found a solution to be what? To be 29. Can you say 29?
29.
So we are going to watch a video. I will ask one of the students who is very good in ICT to come forward and play for us the video. Maina, please come forward and play the video for us.
Okay, teacher.
There's chicken in class. Chase it outside.
In this lesson, we shall try to find the missing number. We have been given a number, but we have one that is missing, and it is represented by. So what we have been asked to do is to look for what it is that we shall add from 13 so that we can get 19. That is, how many numbers are in between 13 and 19? Because if you add them, you will get 19. So how do we do this? One of the ways in which we can do that is by doing simple calculation of addition. We want to add 19. So let's add that should be the 14th one. 15, 16, 17, 18, 19. So if we are to get 19, which we have been asked to look for, and we had been given 13, which is up here, then what we need to add are these that have been missing. Let's count them together. 1, 2, 3, 4, 5, 6. So what we need to add is 6, which means that the unknown number here is 6. Let's check if our answer is correct. If we say 6 plus 13, so we have 1, 2, 3, 4, 5, 6, plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. If we count them together, it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, which means our answer is correct.
Good.
Okay, and now proceed. Will you share screen?
Yes. Let me share my screen. So that is what we did yesterday. And you realize that those were routine problems and we learned how to solve them, right? So I would like you to look at this today. We are going to look at non-routine problems. Class, say non-routine problems.
Non-routine problems.
Good. So I have this equation. I would like you to find the missing numbers. Find the missing numbers.
Teacher, we write on the chart.
Yes, right on the chart. Thank you, student Esther. And student Patricia, are you leaning on your table? Are you feeling unwell?
Yeah, I'm feeling, I'm just trying to see the questions clearly.
Okay,
Yeah.
good. Okay, let us give the answers. Read for me the chart, someone. I can't see the chart from where I am.
Okay, let me read for you.
Yes, please.
Minus says 6 plus 15 is 21. Michael's Julianera says 1 is to 6, 2 is to 0. Michael Awero says 6. Edith says 6. Minus says 10 plus 3 is 13. And 1 plus 12 is 13.
Good.
Then Lynette says 6.
Uh-huh.
Esther says 1, 6, and 2, 7 plus 6, 13.
Yes.
6 and 7, 6 plus 15 is 21.
Uh-huh. Okay. So notice that for the first question, we have a specific answer, but for the second question, it only depends on what the student wants the answer to be, right? It depends on what you want it to be, all right? Somebody said 10 plus 3, 13. Somebody said 12 plus 1, 13. Another one said 9 plus 4 is 13. So there are various ways in which we can solve that one. Now, there is this puzzle, children, that I want you to do. Remember the puzzles you were doing last time? We have another puzzle here that I would like you to do. A square plus 13 equals to 20. 12 plus a circle equals to 17. A square plus a triangle plus a circle equals to 25. What is the value of the square, the value of the triangle, and the value of the circle? Please take a moment and think about that. What is the value of the square, the triangle, and the circle? Take a minute to solve that.
Maybe they can also show how they come up with the answer.
Yes, Esther, what are you saying?
They can show how they come up with the answer.
Yes. Please show how you come up with the answer. Okay. Anything on that, Student Esther? And where is Student Huntington today? I can't see him. Is he in class today?
Teacher, Maina says
Huh?
17 minus 12 equals to 5 for the circle.
17
Then-
minus 12 equals to 5 for the circle.
Then 25 minus, maybe he can explain himself.
Yeah. Student Maina, please explain yourself.
17 minus 12 is equal to 5. So the circle is equal to 5.
Okay. So Maina has found the value of the circle. Is there anybody else who has found the value of the square? Esther, in the chat?
I am checking.
Teacher, on the WhatsApp, Nancy has found the value of the square, the triangle,
Yes.
and the circle. So Nancy can tell us how she got it.
Student Nancy, please tell us how you arrived at your answer. First, tell us how you found the value of the square. Then the value of the circle has been given by Student Maina. Tell us how you got the value of the square and the triangle.
Okay, the value of the square, I got it by taking 20 minus 13. I got 7.
Yes.
I got 7. Then for the circle, I took 17 minus 12. I got 5.
Okay.
Then for the last one,
Yes.
since you already know the value of the square is 7,
Yes.
I added 7 plus the value of the circle, which is 5. Then minus, I took 25 minus the value of the circle and the value of the square. So I got 13 as the value of the triangle.
Yes, you got 13 as the value of the triangle. Please clap for Student Esther. Not Esther, Student Nancy. Thank you, Student Nancy.
Yes.
Good. So that is how she arrived at the value of the square, the triangle, and the circle. First, she minus 13 from 20 to get the value of the square. Then, like minus 12 to 17 to get the value of the circle. Now, with the value of the square and the value of the circle plus the triangle totaling to 25, then it means the triangle is 25 minus the value of the circle plus the square. That's how you arrive at it. So thank you very much. Now, we have another problem to solve. When you add 5 to the triangle, you will get a square. If the square is 10, if the triangle is 10, what will the square be? Take another 2 minutes to solve that. When you add 5 to the triangle, you will get the square. If the triangle is 10, what will the square be? Take another 2 minutes to solve that.
Teacher Nancy's hand is up.
Yes, Nancy.
15.
15. How did you get 15? Please tell the others how you got 15. Come to the board and show us how you solve the problem.
Okay, so I took 5 plus the triangle, which is 10. The value of the triangle is 10.
Yes.
So 5 plus 10, you get 15.
Yes. So 5 plus 10, you get 15.
15. Yes.
Okay. Did the others see what she did? Did you see what she did? Student Esther, Maina, Patricia, and the others?
Yes. Yes, we saw.
Good.
Yes.
Very good. Now, so we have another puzzle here that I would like you to solve. Pardon?
The second part is a solution.
Okay, okay. So this is a solution to the first puzzle that we had. The square plus the triangle plus 0 is 20. No, sorry.
No.
Okay.
Just remove the solution.
There we are. Okay. So the square plus triangle plus 0 equals to 25. Into bracket, square is greater than the triangle by 5. So to solve that problem, Student Maina, would you like to show us how this problem is solved? Come to the board and solve for us this problem.
Hello. Okay. Let me come to the board and share. So I'm going to share how I solve the question. So yes. We say that, teacher, you said that
the square.
A square. Yeah, I'm trying to solve it.
Okay.
A square plus the triangle plus a circle is equal to 25. So this is what you told us, teacher.
Yes.
But you also gave us a condition. You told us that the square is greater than the triangle by 5.
Yes, I said that.
By 5. So instead of writing this square here, I can.
Teacher, I cannot see the whiteboard.
Oh. Is it everybody who can see it?
I can
yes.
See it. Esther, you can't see it?
I can't see it.
Oh, so you shared only to me. You only facing the teacher.
No, let me change. Let me not use
so that everybody can see it.
No, it seems that it's only people from the same organization who can see the whiteboard. Okay, let me just share something else. Let me just share my screen. Okay, so teacher, I'm about to work the question you have given me. Let me just try again. So, scanning. So I have replaced, because you have told us that the square is greater than the triangle by, the square is greater than the triangle by 5. So I've said the triangle plus 5, that replaced the square, plus the triangle, plus the circle is equal to 25. So here now I have 2 triangles and the square only, which I'm having here. Then I go again, I say now 2 triangles, because we have 2 triangles plus 5 plus circle is equal to 25.
Yes.
Meaning that if I put a table, because now I know 2 triangles plus circle should be 20. So I have, if a triangle is 1, then 2 triangles will be 2, then the circle should be 18. That I get 20. If a triangle is 2, then 2 triangles will be 4, then the circle should be 16 to get 20. If a triangle is 3, then 2 triangles are 6, then the circle will be 14, that will be 20, meaning the value of triangle and circle is changing. Then I can now take that condition that if a triangle is a particular value, then a square will be a 5 plus that triangle, then I can get the value of the circle. So for example, if a triangle is 1, it means a square will be 6. And 1 plus 6 is 7. And if you subtract 7 plus 25, then a circle will be 18. So teacher, what I'm seeing here is you can have so many answers for the same question.
Yes, it's not one specific answer. I would like you to still move your screen to the next question. And the next question is talking about 3 baskets, a brown one, a red one, and a pink one.
It's about oranges, teacher.
Sorry, oranges. Okay, so we have Juma and Asha combined their oranges. We have a total of 14 oranges. Juma came with 4 oranges more than Asha. How many oranges did each one of them come with? Please solve that problem and put in the chat. I want the rest to solve that problem and put in the chat. Juma and Asha combined their oranges. They have a total of 14 oranges between them. Juma came with 4 oranges more than Asha. How many oranges did each one of them come with? I'd like you to think critically on how to come with that a solution to that. I know we shall have several solutions. The first one to complete will come and show us just like student Maina did.
Juma and Asha. Juma plus Asha.
Yes.
The oranges. 14. Juma came with 4.
Somebody's
solving for you.
Okay. Please repeat again so that we can hear properly.
From the WhatsApp,
yes.
Nancy says Juma 9 and Asha 5.
Okay, who is that somebody? Could they solve for us?
Nancy Mushiri.
Oh, student Nancy Mushiri.
Yes.
Okay. Please tell us how you arrived at that. Or maybe we could pick on another student. Is there any other answer apart from that?
Yes,
Teacher.
there is Cairo Francis.
Yes, Cairo. Cairo, please tell us how you arrived at the answer. Unmute yourself and tell us how you arrived at the answer. Student Cairo. Cairo. Student Cairo, unmute yourself and solve for us.
Yes.
Good. Yes. Solve for us.
Yes, we are told that Juma had, both Juma and Asha had 14 oranges.
Yes.
And then we are again told that Juma had 4 more oranges than Asha.
Yes.
So if we could assume that, we can assume that Asha had an X. Then it means Juma had an X plus 4.
Yes.
So if we take the X plus 4 we add to Asha's x,
Yes.
Which we are supposed to get 2x plus 4. We are supposed to, if we add them together, we have 14.
Yes.
Then we take 14, we minus 4,
Yes.
we have 10. Then 2x is the same as 10.
2x the same as 10, yes.
A single x is equals to 5. Is equal to 5.
Yes.
The x was for Asha.
Yes.
That is 5.
Yes.
And Juma had an x plus 4.
Okay.
So Juma has 5 plus 4, which is 9.
Good.
And Asha has a 5.
Okay. So Juma
Yes.
had 9 oranges
Yes.
and Asha had 5 oranges. Okay, good.
Yes.
So
I did
please let us give him some flowers for doing that. Good. There's somebody else, Mercy Maura, who wants to show us how she solved. Mercy, go ahead. Your hand is up.
I'm taking J to be Juma and
Yes.
L to be Ash. Also,
Yes.
Juma
Yes.
had before oranges more than Asha.
Uh-huh.
So I take it 4 plus A, which is
Yes.
representing Asha.
Yes.
Then now plus Asha herself. That means
Yes.
I have 4 plus A, which is because all of them had a total of 14.
Yes.
So 4 plus A, we have
Yes.
A, which is equals to 14
Yes.
minus 4. So 2A is
Yes.
equals to 10. Then I get A, which is 10 divided by 2, which
Yes.
is 5.
Yes.
So, which is, so when I come to Juma now,
Yes.
I take Juma, who had 4 oranges more than Asha.
Yes. Go on. She has hung, eh? The network is not.
So
And
teacher,
now,
I did it.
Okay.
that is
Okay,
Juma
there she is.
plus whereby I have seen as 4. So I'm saying 4 oranges more than Asha, and I
Yes.
have seen Asha had before. I take 4 plus 5, which is 9. So and
9.
Asha had brought 5.
Good. Nice. So that is
And
yet
that's
another
my
way
answer.
of solving that
Teacher,
problem. Yes.
9
Yes,
plus
China.
5
Teacher,
is
may I get confused with R and X?
with
Minus says he gets confused with the X
X.
and
I'm
J.
saying this. I'm
Yeah,
taking
I
J.
did it differently. Can I show? Teacher, can I show my way?
Yeah.
Yes, you can show your way. Yes. Thank you, Mercy. Thank you, student
Yeah.
Mercy.
I get confused with,
But your
I
answer
get
is correct.
confused with X and R. Yeah,
Yes.
so for me, I did a table and I wrote for Juma and Asha, and then I say if Juma has 4, then Asha will have 0, and the total will be 4.
Yes.
And then I kept increasing. Then if Juma has 5, Asha will have 1, the total will be 6. If Juma has 6, Asha will have 2, the total will be 8. If Juma has 7, Asha will have 3, the total will be 10. And if Juma has 8, Asha will have 4, the total is 12. And if Juma has 9, Asha has 5, the total is 14.
Okay.
So that is how I worked it out, teacher.
Okay, good. So you can see there are various ways of working the same problem. For Maina is confused with the letters, so he went ahead and used the table. Okay. For the first student, he used X, and for the second student, Mercy used J, and they still arrived at the correct answer. That is 5 oranges for Asha and 9 oranges for Juma. Let's move to the next slide. Student Maina, you are in control. So this one is talking about baskets. You have 3 baskets, a brown one, a red one, and a pink one, holding a total of 10 eggs. The brown basket has 1 more egg in it than the red basket. The pink basket has 3 more eggs than the red basket. Okay. How many eggs? Please move ahead. How many eggs are in each basket?
Yeah. Can't see the screen, please. You can't see the screen.
You can't see the screen?
Yes.
Okay. Aina? Can I share mine?
I can see it clearly.
I also can see
Let's
it.
try to share yours. It's taking time to refresh. Yeah, share yours.
Can you see my screen, people?
Yes.
Good. So we have done this. This is what student Maina showed us. So this is where we are now. There are 3 baskets, a brown one, a red one, and a pink one, holding a total of 10 eggs. The brown basket has 1 more egg in it than the red basket. The pink basket has 3 more eggs than the red basket. How many eggs are in each basket? Okay, take 2 minutes to solve that. 2 minutes only. The first one, first come, first serve. There's a prize. There's a prize for the person who will be the first to get the correct answer. Two minutes.
Teacher Jeremiah has got it.
Yeah.
Jeremiah has got it from the WhatsApp. He says they are brown are 3, red are 2, and the pink are 5.
How did you arrive at that, Jeremiah? How did you arrive at that? Jeremiah, please tell us how you arrived at that.
Hello?
Yes.
Grace? Yes. Now I can see there are 3 baskets and there are 3 baskets. A brown one, a red one, and a pink one.
Yes.
I have drawn the 3 baskets. The first basket is brown.
Yes.
The second one is red. The third one is pink. So we are being told the brown basket has 1 more egg. Has 1 more egg in there? doing everything properly, but let me just try to figure out what I'm doing.
Yes.
There are in total there are 10 eggs, yeah?
Yes.
So in my brown basket,
yes,
I'm going to put 3 eggs.
Mm-hmm.
My red basket, because definitely my red basket has 1 more egg than the pink basket. My red basket has 4 eggs.
Mm-hmm.
Then my pink basket has 3 eggs.
Yes.
When I put all of them in total,
Mm-hmm.
I start counting from the first basket is brown.
Mm-hmm.
I will go to red, then pink.
Mm-hmm.
So I start with brown.
Yes.
1, 2, 3, 4, 3. That is 3 for the first one. Then go to the second. 3, 4, 5, 6, 7. That is for the brown and the red basket.
Yes.
7. Then the last basket, which is pink. 7, 8, 9, 10.
Yeah.
So in total, I am holding my 10 eggs in the 3 different baskets.
Okay.
Yes. So brown
Good.
has 3 eggs, red has 4 eggs, and pink has 3.
Okay.
Because the question there is asking how many eggs are in each basket.
How many eggs are in each basket? Good. So that is how she worked it. But this is how the teacher also worked it. That we have red basket, pink basket, and okay. Brown basket, red basket, and pink basket. So that is what you have. So red has +1, pink has -3, and red has +3. So is this the same as what you got? Yes.
Hello.
Hello.
I'm Lucy.
Lucy, yes.
I want to use the method Mr. Miner used for was it the last?
Yes.
The second last question.
By using the table, right?
Yeah, using the table.
Good.
I'll
Yes.
draw 1, 2, 3, 4 columns. One for brown, one for red.
Yes.
Another one for pink, and then the total.
Good.
I'll start with the red one. If red will not have anything, brown will be having 1 and pink will be having 3, because pink is having 3 more than red and brown is having more than red.
Yes.
If I put 1 in red, brown will be having 2, pink will be having 4, and the total will be 7.
Yes.
And then if I put 2 in the red basket,
yes,
brown will be having 3 because it will be having 1 more than red. That is, it will be having 3, and then pink will be having 5 because it is having 3 more than red.
Yes.
And then it will be 10. So I'll be having brown 3, red 2, and pink 5.
Good. So it is the same as the answer that the teacher has on the board, isn't it?
Yeah.
You have used the same method. Let us clap for both students. Let us clap for them. Good. Very well. So you can see that there are various ways of solving the non-routine problems, and all the various ways lead us to the answer or to the desired answer. So what did you enjoy in today's lesson? What did you enjoy in today's lesson? Note down one thing in the chat that you enjoyed in today's lesson, in today's mathematics lesson in solving non-routine problems.
The teacher was clear.
Yes.
The teacher was clear, and she was helping us to follow the steps one after the other.
Okay. Okay, good. Anything else you enjoyed in today's class?
Teacher, the English
It also
teacher is
helps
on
it also helps the pupil to be more practical and to get to I mean it gets the pupil to be hands to be able to know and to capture what is happening.
Okay, good.
Teacher, the English teacher is waiting at the door.
Okay, so the English teacher is already at the door. I will be stepping out shortly. Good. So for your home fun, I would like you to work out this one. For your home fun, place the numbers 1 to 9, one in each circle, so that the sum of the numbers along any of the 3 sides of the triangle is 20. There are 9 circles and 9 numbers placed in the circles. Each circle must have a different number in it. Okay? So that is what I would like you to go and do for your homework. You will also find it in the Google Classroom as soon as you leave here. Okay. So any feedback for today's session? Time for feedback for today's session? The entire session?
We are enjoying the issue of online program.
Yes.
And we are not taking it for granted.
Okay.
It has come at the right time.
It has come at the right time. Good.
And we are learning a lot. Now it has now reduced our fears. We were a bit uncomfortable.
Yes.
But now we are getting on well.
Slowly we are getting on well. Thank you very much.
Trying hard.
Anything in the chat? Anything in the chat, Esther? Just one before we move on. Remember the feedback, the pips. Remember the pips? Anything in the chat, Esther?
Somebody says good voice projection involving learners provoked critical thinking. Then the other person says, that's Karen, keep up for being creative in your lesson. Imagination is real.
Good. So I think we shall read the others, but I would like you now to think about yourself. And we shall use this phrase. I used to think, but now I think. Okay? Just tell us what you used to think, but now you think. Take a time and write that in your chat. I used to think, but now I think. We have 1 minute remaining. Please let us do that quickly. Esther, as soon as you see one hitting the chat, let's read it and move on.
Okay.
Student Patricia, are you monitoring the WhatsApp group? Is Student Patricia with us? I used to think, but now I think.
Leah Musa says, not yet. It's not complete. It's halfway.
Okay.
Somebody says that is Ann Benson. I used to think ICT integration is hard, but now I see it is easy.
Good. That's a very good general observation for the entire sessions.
Then Juniela says, I used to think that I can only use one method to solve routine problems, but now I have diverse solutions. Then John Kibe, non-routine problems are challenging and hence require a lot of concentration, but I had network challenge. That's an expression. Kathy says, I used to think that non-routine problem solving was difficult, but now I think it is doable. And finally, improve on speed. Sometimes you are too fast. Thank you, Edith.
Okay, good. That is good feedback. Thank you. So now I would like us to go back to building a professional learning experience and populate our portfolio. Take a minute to populate your portfolio as we are concluding today's session. Populate your portfolio. One minute to populate your portfolio. And as you are populating your portfolio, I would like you to design an online lesson that you will teach between grade 1 any class between grade 1 to grade 4. It should be a numeracy or literacy lesson. It should have essence statement, specific strands and sub-strands. It should have students' learning outcome, foundational skills, competencies, abilities. Most importantly, it should have learning experience and learning activities. It should have a reflection, just like the one we had, and it should also have assessment, both assessment for learning, assessment as learning, and assessment of learning. So you will have a working break and you will develop that lesson. When we come back to class, you will present the lesson. We shall select a person at random who will present the lesson. So this is a working break. Please don't rush out to play in the field. Go and take your tea quickly, sit somewhere. Yes. And prepare
I think
that.
we also had names for people who are going to present today.
Yes.
Can you remember the names we had yesterday? Was it Nancy Mushiri and Jay Kims?
Yeah, Jay Kims, yeah. So Nancy Mushiri and Jay Kims, please be prepared. I think we'll begin with your lessons, and then we shall select other groups to present as well. So use that format that is there. Use that format that is there on the presentation, and prepare a lesson that we'll present in the next exactly 1 hour. Good. So let us unmute.
Thank you, Enos. Can you give Enos, can you give Kathy to give a closing statement?
Yes. Kathy from South Africa, please give us a closing statement.
Is there anyone out there from South Africa apart from me? Just me. I enjoyed that session very much. And I think that problem solving is probably one of the most, well, non-routine problem solving is probably one of the most important skills we can teach our children. Yeah. Just because the world has changed so much. And it is, as you had that saying, that we are actually teaching children for a world we don't know, that with problems that we have no idea are coming at us. And straightforward routine problem solving are not going to solve those problems. So we need to teach children how to do non-routine problem solving, be able to think differently out of the box using strategies perhaps they haven't used before, to prepare them for a world that's coming. For example, if we thought back to Christmas of last year, December of last year, would we have foreseen that COVID would have completely shut down our world 6 months later? And when you consider how many different scientists, doctors, medical people all over the world are working together now to find a solution to a vaccine, a way to combat COVID, I think that's such a good example of what non-routine problem solving is all about. So thank you very much once again for having me, and I'm really enjoying this. Thank you very, very much.
Thank you. Thank you too. Okay, so I think we've come to the end of our first session. Unmute your cameras and let's say bye to each other. We shall come back at exactly 1 hour from now. Remember, it is a working break, so rush, take your tea quickly, and then you join us after exactly 1 hour. That should be exactly 10:33. Good. Thank you. So see you in the next session. Bye-bye, everyone, and thank you for being with us in this session.
Bye-bye.
Bye.